January 1944, Westward Ho, North Devon. A landing craft sat off the surf line in winter light. On its ramp stood two 10-foot wheels and a loaded axle drum. Men on the pebble ridge watched through binoculars and smoke. They were waiting for a machine designed to run itself into concrete. Instead, witnesses later described a machine that hunted its own side. The object was the Great Panjandrum. Its purpose had been deadly serious. The requirement came from invasion planning, not eccentricity. DMWD had been asked to solve a narrow assault problem. Reports described a reinforced concrete barrier on enemy beaches. The wall was said to be roughly 10 feet high. The wall was said to be about 7 feet thick. A tank-sized breach was the minimum acceptable result. The beach in front was expected to be mined. The same strip was expected to be under machine gun and mortar fire. Hand-placing a demolition charge at the wall was unlikely to survive. The engineering problem was delivery under direct fire. Published accounts from the DMWD circle put the charge at 1 ton. It had to be launched from a landing craft. It had to remain controllable long enough to hit concrete. The concept came in 1943 discussions around combined operations. Gerald Paul's account places Group Captain Finch Noyes at the start. Content reference, OE-site. Index 3. His rough idea was brutally simple in outline. 2 huge steel-rimmed wheels would carry a central explosive drum. Slow-burning cordite rockets would ring the wheel circumferences. The machine would be rolled aboard a landing craft and fired off its ramp. Once lit, the rockets would drive it like a giant Catherine wheel. Content reference open bracket OAI site :4 close bracket open brace index equals 4 close brace. If momentum held, the frame would smash into the obstacle. If the wheels collapsed on impact, the explosive drum would continue forward. A mechanical firing arrangement would then detonate the load. In theory, it replaced a suicidal demolition party with a rolling charge. The design assumed traction on uncertain sand. Neville Shute Norway took the concept seriously. He was a DMWD officer and engineer, later better known as a novelist. Powell's account says Norway judged the idea the only plausible answer. Williamson, one of DMWD's key assistants, joined the design work. Plans for a prototype went to contractors at Leytonstone. Construction began in early August 1943 under secrecy controls. Content reference. A site. Index 6. The frame had to survive launch, surf, and sand drag. The frame also had to fail at the target. The wheels were about 10 feet in diameter. Their treads were roughly 1 foot wide. The axle section was a drum intended for the explosive load. Content. Reference open bracket OAI site, :7 close bracket, open brace index equals 7 close brace. Design estimates aimed for around 60 miles per hour on the run-in. The name arrived before the trials. Norway called it Panjandrum, drawing on Samuel Foote's nonsense verse. Powley preserves the line about gunpowder running from its heels. The joke fit the machine too well. Paul notes that Williamson was omitted from the list by mistake. The prototype was built inside a hut effectively wrapped around it. When construction finished, part of the shed had to be removed. Only then could the machine be rolled out. Transport west was done at night under police escort. Holidaymakers crowded around the machine on the beach. They inspected rocket brackets with the curiosity of seaside spectators. The project was secret in paperwork and public in geography. Combined operations had Cox facilities around Appledore and the estuary. The beaches offered open sand, surf, sheltered water, and varied gradients. Westward Ho, in particular, matched projected tidal and beach conditions. Every grain condition altered rolling resistance. Every patch of soft sand changed the thrust balance. Every crater threatened to redirect the whole frame. The maiden run came on the 7th of September 1943 at Westward Ho. The central drum was ballasted with 4,000 pounds of dried sand. The sand replaced explosives for obvious reasons. No one present trusted the first ignition enough for a full rocket load. Only 18 rockets were fitted for the opening attempt. Content reference. OE-site. Index 10 styles. Smoke and flame wrapped the wheels as it dropped down the LCT ramp. It ploughed through the shallows and climbed onto the beach. For a moment it held a reasonably straight line. Then 2 rockets on one side failed to ignite. The machine swung off course to starboard. Powley records the first run ending after about 220 yards. Sand drag was far higher than the designers had assumed. Without more thrust, the 60 mph plan was unreachable. Without that speed, the wall concept lost its logic. The team doubled rocket count by adding inner wheel positions. Extra rockets were flown in for rapid modification. Welding support failed on the British side at Cox. An American Army unit supplied a generator truck and welders. The job was finished quickly because the tide and light were closing. The next trial moved to Instow Beach inside the estuary. The machine covered water successfully before reaching the target marker line. Then loose, uneven sand slowed it sharply. Rocket failures appeared again under load. It swerved and stopped after roughly 406 yards. The run was longer but still too slow. More rockets improved thrust but worsened stability. Back in London, DMWD held what Powell calls an inquest. Captain Jeans presided. With combined operations and DMWD staff present. Williamson proposed a third wheel to improve stability. The propulsion debate exposed a deeper design uncertainty. Norway favoured more speed for straighter running. Guggenheim argued for gentler acceleration and control. The immediate decision was blunt. Rocket numbers would be increased again. Content reference. Oisice. Index 13 down. The wall still had to be breached from a landing craft. Panjandrum remained in contention because the assault problem remained unsolved. On September 27th, a three-wheeled Panjandrum was prepared at the shore. A wooden ramp was built near the waterline for the test. Then a wiring fault halted the firing circuit. The crew worked against the tide to clear it. The tide won. Seawater rolled in and engulfed the machine. The centre wheel collapsed before the run began. Some rockets were salvaged from the flooded wreck. The weapon then disappeared into repair for about 3 weeks. The Surfline itself became a destructive test rig. The next outing used a heavier rocket fit. Paul describes more than 70 rockets on the third trial. The result was spectacular and worse. As the machine reached the waterline, it veered back toward the sea. It heeled until the flanges dug into sand. The frame lurched and overturned. The impact tore rockets loose from their clamps. Some flew low across the beach. Others kept burning on the wheel while partly underwater. Steam and smoke obscured the machine and the shoreline. The third wheel experiment ended in distortion and wreckage. DMWD then abandoned the centre wheel approach. Panjandrum would be steered by braking, not just by wheel grip. The steering system looked ingenious on paper. 2 long cables were connected to braking gear on the axle. Naval kite balloon winches controlled the drag on each side. Norway and Williamson each manned a winch during trials. Powell records the cables as 1-ton cables 2,000 feet long. Content reference, Oisice. Sus. Indexed 16. The sand was ribbed, wet and soft on one key run. Panjandrum accelerated well, then the port cable snapped near the machine. The broken wire came back like a projectile. Both operators dropped flat into wet sand to avoid it. Another run proved the idea had some effect on course. Another cable snap ended that confidence quickly. Trials paused again while heavier wire was sought. It had become more controllable and more hazardous at the same time. Content reference. Oisice. Index 17. On 12th November, with heavier wire and revised winches, they tried again. The beach was hard and smooth that day. A marker post was set 250 yards downrange. Panjandrum was steered toward it through smoke and crosswind. One rocket burst free around halfway through the run. Another was released with it. Powell still judged the overall trial broadly satisfactory. Norway remained unconvinced. Norway's concern shifted to torque and wheel slip on sand. Too much thrust reduced grip. Reduced grip destroyed directional control at the wheel. A brake system could not correct a machine already sliding. The design had reached its contradiction. The same day produced the retention spike that doomed confidence. The team decided to test over craters simulating mined beach damage. 3 rows of mines were blown to create the broken surface. Panjandrum ran faster than before. Steering became erratic almost immediately. The machine traced a sinuous path under brake inputs. After roughly 140 yards, it lurched hard to port. Norway released the load on the steering system to recover it. The winch wires overran and locked. Panjandrum pivoted toward the sea and stopped. The violent turn distorted the starboard wheel. The team returned to the hotel dejected. Powell's account describes a machine with no end to its temper. A new brake type and angled tyres were discussed. No quick fix existed for the sand itself. The rockets were not designed for sustained lateral centrifugal loads. Above roughly 50 miles per hour, rocket failures became common. One burst often damaged the attachments beside it. Detached rockets then skipped across the beach at shin height. Powell describes them as 20-pound ironmongery. He also gives a burn time of about 40 seconds. He also gives thrust at about 40 pounds per rocket. Spectators and cameramen repeatedly found themselves in the path. WM film metadata later described rockets skittering across the beach. It also records cable trials and near-camera loss of control. It was a recurring engineering condition. No more trials were run before year-end. Modifications continued in London. Powell states that 2 new Panjandrums were built. Then another change arrived from planners. Close steering accuracy was no longer considered imperative. The decisive trial came in early January 1944. The version loaded onto the LCT looked like a reversion. It had the original 2 big wheels. It had a central chamber ballasted with 2 tons of sand. It carried no steering gear. The morning run used 48 rockets. Norway hoped for about 65 miles per hour. Paul records that it did not even reach 50 over 800 yards. Content reference. Hawaii site. Index Skin 21. After lunch, senior observers assembled on the Pebble Ridge. Admirals, generals and scientists came to judge the result. Whitehall was effectively conducting a field verdict. 2 minefields were detonated to cut craters into the course. The photographer Louis Clementaski took a position halfway up the beach. Pauli places an Airedale there as well, named Amanal. The machine waited far down the strand on the landing craft. Abel, behind sandbags on deck, held the firing key. Then the signal came. The launch looked slow and controlled for a few seconds. Clementaski later compared the sight to a rocket missile departure. Within the opening yards, a rocket burst from its clamps. Then 2 more broke free. The machine was now faster than any safe test condition allowed. Pauli writes that Clementaski thought it near 100 miles per hour. The beach became a corridor of smoke, flame, and noise. At about 80 yards, it crossed 1 crater line. At roughly 120 yards, the loss of control was obvious. The shoreside wheel dipped. The whole frame arced towards starboard. Clementaski kept filming until the machine was aimed at him. Then he ran with the dignitaries over the Pebble Ridge. They dropped into barbed wire on the far side to get clear. Content reference. Worksheet. Index 22. The machine did not crest the ridge. It curved back toward the sea instead. From the ridge top, the observers saw the end. Panjandrum had fallen onto its side on the sand. Rockets trapped underneath were smothered. Rockets on the upper side kept burning and detonating. The frame twisted under uneven thrust and repeated bursts. More rockets tore free and shot across the beach. Powell's account keeps the Airedale in the scene, chasing the missiles. When the smoke cleared, the dignitaries walked down to wreckage. The frame was blackened and distorted. The tide was already reaching it. Here it could not deliver controlled demolition from a landing craft. Content reference, OSite. Index Gestern 23 hours. Post-trial discussions did not stop instantly. Paul notes suggestions for special treads on the steel tyres. Others proposed removing the tyres and running on spikes. Those ideas addressed traction and stability. They did not solve the worst safety problem. The rockets themselves were now the decisive objection. If clamps failed on the beach, men could dive for cover. If clamps failed on the landing craft, the launch crew had nowhere to go. Powell's account says that risk sealed the weapon's fate. The project was abandoned before operational issue. It was never used in action. It was designed, fabricated, transported, instrumented, and repeatedly trialed. That is what wartime pressure looks like in development records. Content reference OSite. Index 26. The tactical flaw is often described as lack of guidance. DMWD did attempt guidance through cable braking. The deeper flaw was control authority. Steering was weak because traction was weak. Traction was weak because the required thrust was extreme. The required thrust was extreme because the payload and target were extreme. Every fix amplified another stress. More rockets increased speed but increased clamp failures. More structure increased strength but increased weight. A third wheel improved stability on paper and collapsed in surf. Cables introduced steering and introduced lethal recoil. Relaxing accuracy requirements reduced mission demands and changed nothing. The machine remained vulnerable to asymmetry at every stage. Panjandrum failed as a system, not as a single part. DMW operated under the Admiralty as a wartime special development body. Panjandrum became the dead end that left the best film. Powley also argues the Devon work informed later DMWD efforts. He links the Panjandrum trials to progress on the Alligator project. He noted that Normandy beaches did not present the exact wall described. He speculated that the proposal may have been allowed to leak as deception. That remains a post-war suggestion rather than a settled finding. DMWD designed against the requirement it was given. It could not even guarantee that minute. The footage preserves the paradox better than the legends do. Then the ignition starts and every simple shape becomes a hazard. IWM film descriptions show 2-rim and 3-rim versions. They show ignition circuits, tether experiments, and cable control trials. They show the machine veering toward the camera position. They show operators unbolting damaged cables after runs. They even preserve the dog in the frame during the 3-rim trial. Each reel records another reminder that power is not guidance. Content reference Website. Index 30rem. By the time the project ended, the numbers told the story. 10-foot wheels could be built and launched. A 4,000-pound sand ballast could be carried in the drum. Dozens of cordite rockets could move the frame at frightening speed. Cables 2,000 feet long could influence its path for moments. None of that produced a reliable breaching weapon. The measured consequence was simple and decisive. Not one trial sequence demonstrated a consistently safe straight assault run. That failure was enough under invasion timelines. Beach clearance tools had to be dangerous to the enemy, not the launch crew. Panjandrum remained dangerous in the wrong direction. Senior officers came to watch a solution for a fortified shore. They watched a prototype outrun its own control. They watched rockets strip away and turn the beach into a hazard zone. They watched a machine built to break a wall break itself. The Great Panjandrum looked like a demolition roller. It behaved like a guided weapon with no guidance. Its cost was measured in time, material, and risk accepted in rehearsal. Its legacy was a lesson paid for before D-Day. A weapon can be powerful and still be tactically unusable. Panjandrum remains the Atlantic Wall idea that turned back on the sand.